Welcome back to part 2 of the final exam review for Math 310. We're looking at chapter 14. On your handout, you're on page 1, number 2, and it says solve 9x squared minus 4 equals 0. So we are taking the factoring skills from part 1 and using them to take it a step further and actually solve an equation. When you are using factoring to solve an equation, what you are trying to do is create that equation to have two factors multiplied together that equals 0. And the reason you're trying to do that is because if two things are equal to 0, then that means one of those things has to equal 0, or else it will never equal 0. So if we can multiply these things out into two factors, that means factoring, and we can make one of those factors equal 0 and then make the other factor equal 0, we can solve for what values of x will make this equation true. Now 9x squared minus 4 equals 0 is a difference of squares. The roots, 3x and 2, are both the perfect square roots of those numbers. So now we have a difference of squares, and when we have a difference of squares, we add the roots and we subtract the roots. Okay, now we have two things multiplied together to equal 0. So we can find values of x that make this true by setting each thing equal to 0. Either 3x plus 2 has to equal 0 or 3x minus 2 has to equal 0. Subtracting 2 from both sides, we get 3x equals negative 2, and then dividing 3 to isolate x, we get x equals negative 2/3. In the other equation, we add 2 to both sides, 3x equals 2, and divide by 3, x equals 2/3. Let's see if I got the right answer. I'm going to plug x equals negative 2/3 into our original equation. Instead of 9x squared, I have 9 times negative 2/3 squared. Minus 4 should equal 0. So 9 times negative 2/3 times negative 2/3 minus 4 should equal 0. 9, a negative times a negative is a positive. Multiply the numerators and denominators. Okay, when you multiply a whole number times a fraction, you should change the whole number to a fraction. Then you should cancel anything you can. And then what you have left, in this case, is 4/1, which is 4, and it checks. You should do the same thing with x equals 2/3, and you'll find the same thing is true. It does check out. So our answers are x equals negative 2/3 and x equals 2/3. When you enter them into the computer, you should enter them like this, with no brackets, no parentheses, or anything else. If you put parentheses, that means you're telling me this is an ordered pair that you can plot on a graph, and the first version is x and the second one is y, but that is not what this is. This is not an ordered pair with an x and a y. We don't have any y. This is just two answers, so you type it in like that, separating them with a comma. Let's review chapter 15. In the problem number 3 on page 2, you are going to divide x squared minus 4 over x divided by x minus 2, x plus 2. Division of fractions requires the KFC rule, which means you keep the first term, you flip the second, and then you change division to multiplication. These two expressions mean the same thing. So when you're dividing fractions, you want to change it to multiplication. Let's take a look at this. Is there anything that we can cancel? A mistake a lot of people make is thinking that they can cancel this x with this x, or this x with this x. You can't do that. When you have things added together, you can't cancel them unless the whole binomial that is added can be canceled, because what you have here are you have things multiplied together. They're factors. You can cancel factors, but you can't cancel terms within factors. Okay, so we have nothing that's cancelable. But look at the x squared minus 4. It's a difference of squares. It's x squared and 2 squared. So we can rewrite that as x plus 2 times x minus 2 over x, and then it's going to be times x plus 2 over x minus 2. I like putting parentheses around binomials to remind me that those are factors that can be canceled. So my x minus 2's cancel, and nothing else cancels, so I'm left with x plus 2 times x plus 2, which is x plus 2 squared over x. In number 4, we are going to subtract 4 over y minus 1 minus 4 over 1 minus y. Okay, let me remind you about opposites. Y minus 1 is opposite of 1 minus y. And so if you multiply 1 minus y times negative 1, you get y minus 1. Because they're opposites. So the opposite of an opposite is what you start with. So let's check that out. Negative, distributing it, you get negative 1 plus y, which is y minus 1, because when you're adding, you can switch things around. And y minus 1 is the same thing as this. So y minus 1 is the same thing as the opposite of 1 minus y. Notice that our denominators in this problem are opposites. One is y minus 1 and the other is 1 minus y. Let's go ahead and put our parentheses around our binomials. Now, if we take the second equation and multiply it by negative 1 over negative 1, now remember, you can multiply anything by the number 1. And negative 1 over negative 1 is 1. So if we do that, what we get on the second denominator is we get 1 minus y times negative 1, right? And when we flesh that out, we find out that's equal to y minus 1. So by multiplying by negative 1, we have 4 times negative 1 on top, and on bottom we have 1 minus y times negative 1, which we've shown is y minus 1. So now you see we have the same denominator. And 4 times negative 1 on the second fraction is negative 4. So we have 4 over y minus 1 minus negative 4 over y minus 1. And the negative minus the negative is plus the positive. So now that we have the same denominator, we can keep the denominator and combine the numerators, and that gives us 8 over y minus 1. So the trick to this problem is recognizing the pattern. Y minus 1 is the opposite of 1 minus y. If only we could take this 1 minus y and multiply it by negative 1 so that we get its opposite, we would be in good shape. Well, we can do that if we multiply the whole fraction by negative 1 over negative 1, because you can multiply anything by 1 and it doesn't change the meaning of it. So that gives us 4 over y minus 1 in the first fraction. Our second fraction, the denominator, 1 minus y times negative 1, gives us y minus 1. The negative 1 says, I want to make this the opposite of 1 minus y, and that's y minus 1. Or you can look at what we did over here to see how that works out. In the numerator, we still have 4 times negative 1 up here. So now we are going to simplify. 4 minus a negative 4 is the same thing as 4 plus 4. Since our denominators are the same, we can add our numerators and we get 8 over y minus 1. 4b is to subtract two fractions that have different trinomials at the bottom of them. We can't combine our numerators here until our denominators are exactly identical, and right now our trinomials are different. The only way we could get these to have the same denominator without actually factoring them first is if we multiplied the entire trinomials together, which would be a big mess. So what we're going to do is we're going to factor the denominators, and I'm going to just go ahead and factor them, trusting that you know how to factor by this point. If not, go back to part 1 of the exam review and review your factoring. Okay, now we have the same denominators, but this time they're factored. We need to make those denominators identical, so we have to find the least common denominator. Let's write down our two different denominators. The first one is x plus 2 times x plus 3, and the second one is x plus 2 times x plus 1. Okay, are there any binomials that are identical? And the answer is yes. X plus 2 shows up in both denominators, so let's cancel out the other one. For the others, they're both unique, so we circle them, and our least common denominator equals the product of all of our circled binomials. So this tells us that our denominators have to have each of these binomials in them. Look at our first denominator. It has these two binomials in them, but it's missing x plus 1. So all we have to do is multiply both the numerator and the denominator of the first fraction by x plus 1 over x plus 1, because x plus 1 over x plus 1 is 1, and you can multiply anything by 1 and it doesn't change its identity. So see, now in our first denominator we have the denominator we want to have. We need to do the same thing in the second fraction, and in the second fraction we have the x plus 2 and the x plus 1, but we're missing the x plus 3, so let's multiply numerator and denominator by x plus 3. Okay, and now we have identical denominators. So what we're going to do is simplify this, clean it up a little. So in our numerator, we have x times x plus 1 on the first one. So let's write it in that form, x first and x plus 1 second. And then in our second fraction, we have 2 times x minus 3. We have the same denominator, which is x plus 1, x plus 2, and x plus 3. So I'm just going to write that as a placeholder while I simplify my numerator. Be sure to distribute this minus sign, almost made a mistake there, so that the negative 2 goes to the x and then the negative 2 goes to the 3. So we have minus 2x minus 6 over our LCD. So let's rewrite our numerator by combining like terms, and we have x squared minus x minus 6 over, and I'm going to do the LCD. Now we can actually factor the numerator and then possibly reduce this fraction sum. So the numerator has an x and a minus 3 plus 2, and if you FOIL that, you'll see it's the same as x squared minus x minus 6. So now all we have to do is cancel the x plus 2's, and we're left with our answer x plus 3 over x minus 3 over x plus 1, x plus 3.